Today we have very important news about Artemis missions and James Webb, and a lot of news. The James Webb Space Telescope has solved a lot of puzzles and created a few more. In the 2024 Isaac Asimov Memorial Debate, astrophysicist and science communicator Neil deGrasse Tyson moderated a discussion at the American Museum of Natural History in New York. The conversation was between scientists and surrounded the topic of how data from the telescope may be shifting our fundamental understanding of our universe. From discrepancies in the age of the universe to the unexpected brightness of early galaxies, the James Webb Space Telescope has already prompted scientists to reconsider how the early universe once operated, leading to revelations that could trigger major shifts in our models of the universe during the next decade or more of the JWST's tenure. The data from the telescope paints a consistent and consistently new picture of the early universe, said panelist Mike Boylan-Colchin, a theoretical astrophysicist at the University of Texas at Austin. Just because it was impossible to know what the JWST might see, however, doesn't mean scientists didn't try. Still, it was tough. Arguably, the most difficult part, the panelists said, was coming up with basic parameters to base their predictions off of. As Tyson put it, the parameters are like knobs you turn in computer simulations of the universe meant to project outcomes based on hypotheses. To pose an example, panelist Rachel Somerville, a senior research scientist at Flatiron Institute's Center for Computational Astrophysics in New York City, described a study she had worked on that tried to predict what JWST would see. "We turned all the knobs in our models to match the nearby universe," said Somerville, "but something wasn't right. We disagreed with the observations," she said. After looking over the data, Somerville and her team discovered that their predictions would be more accurate if they took into account the increased density of the early universe, which was smaller than our currently more expanded universe, yet contained the same amount of mass.
After 6 decades of launches, the liftoff of the last ever Delta rocket on Tuesday, April 9th, brought with it a change in the way the US sends satellites, interplanetary probes and spacecraft into Earth orbit. United Launch Alliance, ULA, ignited its last Delta IV Heavy rocket to launch NROL-70, a classified payload for the US National Reconnaissance Office, NRO, literally setting itself on fire for the 16th and final time. "It is a bittersweet moment for us," said Tori Bruno, Chief Executive Officer of United Launch Alliance, in a call with reporters. "It is such an amazing piece of technology, 23 stories tall, 500,000 gallons of propellant, 2.25 million pounds of thrust, and the most metal of all rockets, setting itself on fire before it goes to space." That spectacle, which was unique to the Delta IV in its heaviest configuration, was the result of hydrogen building up in the flame trench and then rising up alongside the rocket after it was used to cool down the 3 RS-68A engines to cryogenic temperatures. When the engines fired, the hydrogen ignited and flames lapped at the orange insulation covering the core stage and its 2 side-mounted boosters. "It's why we had nicely toasted marshmallow boosters and the very dramatic effect of a self-immolating rocket before up she goes," said Bruno. The 2 boosters were jettisoned about 4 minutes into the flight, followed by the core or first stage, separating 1 minute and 45 seconds later. A single RL-10C21 engine on the Delta cryogenic second stage then took over, propelling the NROL-70 payload into space. Due to national security concerns, coverage of the launch ceased following fairing jettison at about 6 minutes and 40 seconds into the flight. ULA is retiring the Delta IV and eventually its other legacy rocket, the Atlas V, in favor of its newly introduced Vulcan, which flew a near-perfect first mission in January. The Vulcan was developed to replace both long-flying rockets in all of their configurations.
The next news with us says, Astrobotic to launch mini rover along with NASA's Ice Hunting Viper on next moon mission Colorado Springs. Astrobotic's next moon mission will send not 1 but 2 rovers to Earth's nearest neighbor. The Pittsburgh-based company plans to launch the first ever mission of its Griffin moonlander atop a SpaceX Falcon Heavy rocket later this year. Griffin's main job is to deliver NASA's Ice Hunting Viper rover to the lunar South Polar region. But we learned on Monday, April 8th, that the lander will tote another, smaller rover as well. Also hitching a ride on the Griffin 1 mission is Astrobotic's Cube rover, a modular little machine designed to make moon exploration accessible to a variety of customers. It will be operated using Spacefarer, a software platform developed by the Canadian company Mission Control. What an exciting time in space exploration! As commercial companies are at the very beginning of creating a new market economy on the moon, Lisa Campbell, president of the Canadian Space Agency, CSA, said on Monday during a press conference held here at the 39th Space Symposium. This mission promises to be groundbreaking, a demonstration of commercial space technology, she added. But quite frankly, I think it's just going to grow from here. Griffin 1 won't be Astrobotic's first moon mission. The company's smaller Peregrine moon lander launched January 8th on the debut liftoff of United Launch Alliance's new Vulcan Centaur rocket.
There's a limit to how excited I can get, given that we should have been doing this 45 years ago. so, we were on the moon through 1972. And now we're not on the moon for 50 years. And now you want me to get excited. So no, I'm not excited. It's like, it's about damn time. Does that count as being excited? I don't know. That's a happy frustration. How about that? There's no word for that. I'm happily frustrated that we're going back eventually, that we eventually are going back. And by the way, the time between Artemis 1, which was uncrewed, and Artemis 3, how many years is that? Is that like 6 years or so? Something like that? It's going to be something like maybe 7. And I think to myself, wait a minute. When President Kennedy said, let's put a man on the moon and return him safely to Earth, he said that in 1962. We didn't yet have a rocket that was capable of holding humans that didn't blow up on the launch pad. Okay? In other words, he made that announcement before we had safe passage to space for humans. 7 years later, we're walking on the moon. So I'm still a little grumpy that we start the Artemis mission and maybe 7 years later we go from the first trip to the moon to the first landing of humans on the moon, because Artemis 2 will go to the moon. It's scheduled for late, I think early 2025. The launch date's been shifting and I haven't kept up with it, but the crew has been selected and they're young enough so that however long the delay is, they'll still be young enough to, I think they won't be old and retired and senior citizens before they go up. But so things move faster back then. And I think they moved faster because we were quite compelled, feeling threatened by the Soviet Union because they were making all these advances in space. And right now, our quote threat may be just simply China says they want to put some taikonauts on the moon, and maybe that spooked us a little, but not at the pace that we were spooked back in the 1960s.